Lutetium-149 undergoes a rare type of radioactive decay. This artist's impression shows the decay of a lutetium-149 nucleus into a ytterbium-148 nucleus and a proton. Physicists in Finland have created a pumpkin-shaped atomic nucleus that throws off protons in a rare kind of radioactive decay. The nucleus, lutetium-149, has the shortest half-life of any of a group of radioactive elements called proton-emitters, according to PhysicsWorld. It loses half its radioactivity, decays into other elements, in a mere 450 nanoseconds, the physicists reported March 16 in the journal Physical Review Letters. Lutetium is a rare earth element that appears in its naturally occurring form as a silvery metal with 71 protons and 71 neutrons in its nucleus. It usually occurs alongside the metallic element ytterbium in the Earth's crust. In the 1980s, scientists observed an isotope of lutetium, a variation of the atom with a different number of neutrons in the nucleus known as lutetium-151, decaying and throwing off a proton from its nucleus while in its ground state. The ground state is the lowest level of energy that an atom's electrons can have and its most stable configuration. Proton emission is rare, and lutetium-151 was the first isotope observed to emit protons while decaying in its stable ground state. Studying proton decay allows researchers to peer inside the nucleus of an atom and understand how protons and neutrons bond together. As part of this line of research, Kali Orinen, a postdoctoral researcher in physics at the University of Jyväskylä, and colleagues created a new isotope of lutetium, lutetium-149, which has 71 protons and 78 neutrons in its nucleus. They found that lutetium-149 was even weirder than lutetium-151 had been. For one thing, its nucleus is not a neat sphere, but rather an oblong squashed sphere that looks a bit like a pumpkin. This is known as oblate distortion, and lutetium-149 is the most distorted nucleus ever measured. Lutetium-149's blink-and-you'll-miss-it half-life is also significantly shorter than lutetium-151's half-life of 80.6 milliseconds. The researchers created the isotope by firing an isotope of nickel, nickel-58, at an isotope of ruthenium, ruthenium-96, according to PhysicsWorld. The new lutetium isotope decays to ytterbium-148, which itself does not stick around for long. It has a half-life of 250 milliseconds. According to PhysicsWorld, it might be possible to create lutetium-148, which might last a little longer than lutetium-149. Image credit, University of Jyväskylä.